सबसे पहले देखिएगा वेव ऑप्टिक्स में जो मोस्ट इंपॉर्टेंट प्रॉब्लम्स हैं इट इज बेस्ड ऑन बीटा, दैट इज लैम्बडा डी बाई डी. This beta stands for fringe width. You have the arrangement like this: two slits S1 and S2, D distance apart. Distance between slit and screen is again capital D. The light which we will be using is of wavelength lambda, and then on the screen we will get this type of pattern, which is pattern of maxima and minima. The alternate maxima and minima will be there. The width of this is called fringe width, and that is basically lambda d by d. So the logic is this one only, that how to find the fringe width. Beta equals to lambda d by d. In this concept, if you will see the first concept, if d equals to 1 mm, when we will be using light of wavelength 500 nanometer. Nanometer means 500 into 10 raised to power minus 9 meter. 1 mm it means 10 raised to power minus 3 meter. If capital D is 1 meter, distance between them, then the fringe width expression should be equals to 500 10 raised to power minus 9 1 meter upon D is 10 raised to power minus 3. So the beta will be 500 into 10 raised to power minus 6 meter, or we can say 500 micrometer is fringe width in this sense. This question can also be asked in this manner. From beta equals to lambda d by d, we can also find lambda equals to beta d upon d. If we will be given fringe width of 0.3 centimeter, it means 0.3 into 10 raised to power minus 2 meters. When we use capital D as 1.2 meter and small d as 0.24 mm, जैसे ही आपको कहीं दूसरी कोई क्वांटिटी दिखे सेंटीमीटर मिलीमीटर, सबसे पहले उसको तुरंत उसी वक्त ही आप चेंज कर दें किसी सिस्टम के अंदर. What will be the wavelength of light? Then wavelength of light must be equals to 0.3 10 raised to power minus 2, 0.24 into 10 raised to power minus 3 upon 1.2. When you will solve this expression, you will get 6 into 10 raised to power, or we can directly write it as 10 meter. 10 raised to power minus 10 meter is always angstrom. So we will write like this, that The wavelength must be equals to 6000 angstrom. Question number 3. Formula for beta is upon D. This beta is given as 0.1 centimeter. What will be new fringe width if D and D reduce to हाफ? अब नया जो बीटा डैश आएगा, लैम्डा को चेंज नहीं किया, डी को कर दिया डी बाई टू और स्मॉल डी को भी कर दिया डी बाई टू. ये 2 से 2 गया, कोई फर्क नहीं पड़ेगा. Again it will be 0.1 centimeter only. So be careful. फॉर्मूला अगर आपको सही आता है तो इस तरह की प्रॉब्लम में कभी गड़बड़ नहीं आनी है. बीटा इक्वल्स टू लैम्डा डी अपॉन डी वाला एक्सप्रेशन आप इस तरह से लगा सकते हैं. क्वेश्चन नंबर 4. If frequency is given, देखिए C equals to nu lambda, so lambda must be equals to C by nu. First find wavelength. अगर frequency कहीं पर भी given हो, पहले wavelength find करो इस रिलेशन से. C is velocity of light and then you will apply so this is another experiment with your beta. Question number 5. If medium is involved, then beta dash must be beta by mu. So 1 by mu of lambda d by d. Lambda d and d will not change. We need to insert here another parameter, and one thing is very sure that beta dash is always less than beta because refractive index is always more than 1. So medium में हमेशा refractive index कम हो जाएगा. Seventh problem is, we know condition for maxima path difference and lambda. phase difference, two n pi. We also know position of maxima n lambda d by d. बट एक और चीज ध्यान में रखना यहां पर, what will be the angular position? Angular position of maxima must be x upon d. So that must be n lambda by d. Similarly, if you want to find out position of minima, two n minus 1 lambda d by 2d, and angular position of minima two n minus 1 lambda by 2d. So these are for maxima and these are for minima conditions. Condition for overlapping. N1 lambda 1 must be equals to N2 lambda 2. If two different color lights are there, then N1 lambda 1 must be equals to N2 lambda 2. If lambda 1 is greater than lambda 2, if n1 equals to n, then n2 equals to n minus 1. So in this sense, I can write n lambda 1 must be equals to n minus 1 lambda 2. I can easily find out the value of n with this expression. If two fringes overlap from two different wavelengths, this is the condition for overlapping. With superposition, of the waves, y1 is a sine omega t, we have the resultant equation r as under root of cos phi with the condition r maximum Similarly, we also have conditions for intensity. Cos phi with I maximum and I minimum I maximum can also be expressed in terms of this as k a plus b whole square, and I minimum can also be written as k a minus b whole square. I1 upon I2 a square upon b square, that is W1 upon W2, where W2 is called width ratio. स्लिट विड्थ के रेशियो के हिसाब से भी I1 upon I2 must be equals to W1 upon W2. So whenever we will take I maximum upon I minimum, it should be equals to I2 whole square. If two sources of same amplitude or intensity I dash is I plus 2I cos phi. If you put I1 equals to I2 equals to I. So this I dash becomes 2I plus 2I cos phi. 2I you can take common, 1 plus cos phi. And we can write 4I cos square phi by 2. Two sources of equal intensity.